Hello students, in this video we'll prove two propositions about uniformly continuous functions. Here's our first proposition. Let's suppose that f mapping E into R is uniformly continuous and I give you a sequence xn, n goes from 1 to infinity, which is Cauchy. Okay, then the sequence f of xn is also Cauchy. Okay. All right, so let's prove this. So how does the proof go? We let epsilon be greater than 0 and choose delta such that x minus y less than delta implies f of x minus f of y less than epsilon. And so now, since the sequence is Cauchy, since xn is a Cauchy sequence, it's Cauchy. There is n and m such that if n and m are bigger than or equal to this number n, then xn minus xm is less than delta. Well, if xn minus xm is less than delta, this forces f of xn minus f of xm to be less than epsilon, and that exactly means that the sequence f of xn is Cauchy. So hence, f of xn, n goes from 1 to infinity, is Cauchy. Great. All right, so what's the next proposition? The next proposition is that if f is continuous, if f is continuous on a compact set K, then f is uniformly continuous. On K. Okay, so let's prove this. We can prove this by contradiction. Proof. Suppose that f is not uniformly continuous. If f is not uniformly continuous, then there are sequences xn and yn that reside in K, such that the difference of these things, xn minus yn, tends to 0 as n goes to infinity. But f of xn minus f of yn can be made bigger than or equal to epsilon 0 for some epsilon 0 greater than 0. Okay? That's what it means not to be uniformly continuous. So now, of course, since these sequences are K, there exist subsequences. There exists a subsequence xnk and ynl that converge to a point in K. Two points in K. Okay? But those points have to be the same, because from these two subsequences, I can conclude that what do they have to converge to, those two subsequences, I can choose common subsequences from them. So in other words, since the difference of xn and yn tend to 0, what can we say? I can choose, by choosing a common collection of those subsequences, we can, they will, so then xn minus yn tending to 0 implies that x and k converges to a point x, and that y and k will have to converge to the same point. Then y and k converges to the same point x by this condition over here. Okay, good. Now, of course, they both converge to x. What do we have over here? But we now have that f of x and k minus f of ynk is bigger than or equal to epsilon 0, but these things are both converging to f of x, right? However, as k goes to infinity, this says that f of x minus f of x is greater than or equal to epsilon 0, and that's a contradiction. So in other words, if you're continuous on a compact set, then you are uniformly continuous there. Thank you very much.